Alright, so here is Unit 9, Day 2, and we're going to do some simplifying rational expressions. And if you remember, rational is just anything that can be written as a fraction. So all these here, I got 6 examples of rational expressions. They're all written as fractions. And if you notice, there's one thing they have in common. Well, first off, let me change this. When I hit print, for some reason, all my multiplication signs turn to squares. But one thing they all have in common is they all equal 1. Okay, so 1, 1, if you did some reducing, cancel stuff out, like here, the 3 divided by 3 is 1, 4 divided by 4 is 1, and so on. So and that's kind of what we're going to do today, is looking at factors and seeing what we can cancel. It looks like we're doing a division problem, and we really never actually divide, we just simplify. So this last one here, though, like the 16s, I would reduce to 1 and 1, and then the x's would cancel each other out. So 1 on top, 1 on bottom would equal 1. But what can't x equal? There's one thing that x should not equal, otherwise this expression cannot be computed. Okay, so maybe pause this for a second and think about it. What could I not put? And think about the bottom. What can the denominator not equal? Okay, so hopefully you thought about it. And x cannot equal 0. Because if I put a 0 here, 0 times 16 is 0, and you can't divide by 0. Okay, so can't divide by 0. And that's kind of the biggest idea. You're talking about big ideas. That's the biggest idea of today's lesson, is the denominator, the bottom, cannot equal 0. So is this true? Does x minus 3 divided by x minus 3 always equal 1? And you think no matter what I plug in, if I plug in a 1 here, 1 minus 3 is negative 2, and it's negative 2 on bottom, so that would equal 1. If I put 1,000 in here, that'd be 997 divided by 997. It doesn't matter what you plug in. So this, as an entire binomial, we can think of it as this whole thing cancels that whole thing out, and it does equal 1, except for in one case. So what can't x equal? So think about what would make the bottom equal 0. So what would I plug in here that I take 3 away from to equal 0? And that would be 3. So x cannot equal 3, or else I'd have 0 over 0, and you can't calculate 0 divided by 0. Okay, now one thing that we struggle with sometimes is what's a factor? So what can I cancel? Okay, so like here I said the 16s you could cancel, the x's you could cancel, but here I had to do the x minus 3. The whole thing had to cancel. I didn't do x divided by x and then 3 divided by 3 because this was a minus in between. You can only cancel things when they're being multiplied. Okay, and so here's kind of why. So suppose you're trying to simplify these two things. Okay, now which one can we, and this is not really stated very well, this is which one equals 1, which one has a factor of 1 in it? We say factors of 1, like 16 over 16 is 1, so that's a factor of 1. Here, if you did 4x over x, over x, I would sure be tempted to look at the x's and say, well, I could take x divided by x, and that's 1. So 4 times 1 on top is 4, 1 on bottom, that equals 4. So is that true? No matter what I plug in for x, will that equal 4? So you could just pick a few things, like if I plugged in 1, so 4 times 1 divided by 1, that equals 4. How about if I plug in 2? 4 times 2 divided by 2, what does that equal? 4. 4 times, let's say, negative 3. Let's plug in a negative and see if that changes anything. So 4 times negative 3 would be negative 12. Negative 12 divided by negative 3, yep, that's 4 again. So no matter what I pick here, this one equals 4. So that can be canceled. That's okay. What some students get in trouble with is they look at here and they say x divided by x is 1. So they want to cancel those out. Okay, so let's do this. Let's plug in 1. 4 plus 1 divided by 1, that'd be 5. But what if I tried to cancel those out now? If I cancel those out, it would be gone, and I would get 4. Doesn't work. Or what if I were to, let's see, what if I plugged in a 2 for these guys? So 4 plus 2 divided by 2, well, that'd be 3. So I can't cancel these guys out. So there's nothing no matter when I plug different things in, it doesn't always equal the same thing. Over here, equaled 4 every time, no matter what I plugged in, so I could just cancel the x's out. Here, I can't just cancel the x's and say that it equals something. It doesn't work that way. You know, if I plugged in a 3 instead, well, guess what? A whole new number, I guess 7/3. So since these aren't equaling the same number, nothing can cancel. But here, no matter what I plugged in, I got 4. That means I can just cancel those x's out. The difference here is x is being multiplied by 4, and x is by itself, whereas here x is being added to 4. So we only cancel things that are factors. Factors are things that are being multiplied. That x on top is not being multiplied by 4, it's being added to 4, so you cannot cancel it. If there was, say, a 4 plus x on bottom, like an entire, like this was x minus 3, I couldn't do 3 individually and I couldn't do x individually, but the entire thing I could do, because x minus 3 is a factor of x minus 3, so it can be canceled. Okay, so kind of a long explanation, but that's the typical mistakes I see here. Okay, so going a little bit faster here, and again, we want to state any values that will make the denominator 0, which basically means any excluded values, anything that x cannot equal. So here, I think it's almost easier, find the excluded values first. So before you even start, what could I not plug in for x here? So what would make the bottom equal 0? If you have trouble seeing it, just set the bottom equal to 0. Okay, if I square root both sides, I get x equals 0, and that's exactly it. X cannot equal 0, because if it does, that makes the bottom equal 0. Now what do I get when I cancel? X squared on top, x squared on bottom, that's 1 and 1, so this equals 1. So this expression equals 1 as long as x isn't 0. If x is 0, then it doesn't equal anything. It cannot be calculated, so it's undefined. Okay, over here, x times 3. Well, what would I plug in to make the bottom equal 0? Well, 0. So x cannot equal 0. Now let's do some canceling. So x over x cancels, this x over that x cancels, now I've got x over 3. So this expression, I could simplify it as x over 3 as long as x isn't 0. Okay, here, what would make the bottom equal 0? 0. If I plugged in a 0, 0 times 9 is 0, and that can't happen. So x cannot equal 0, that's my excluded value. But now let's do some canceling here. Okay, so 1, 9's cancel with 9's, x with x's, so I just get 1. Let's see here. Letter D. Again, these are supposed to be multiplying. What would make the bottom equal 0? 0. So h cannot equal 0. Okay, but if I, let's see, sorry, my screen looks like it's not focused. If I do some canceling, so this h can cancel that h, and I'm left with h times k. So this expression equals h times k as long as h isn't 0. If it does equal 0, then that's cannot be calculated. Okay, so undefined. Letter E. Do not cancel the 2's. Do not cancel the x's. But could I do the entire binomial? Absolutely. Okay, so I could cancel those, but let's figure out what makes the bottom equal 0. So what would I plug in here to equal 0? And it would be 2. Okay, if I plugged in a 2, that'd be 0. So now I've got that. Now I can do some canceling, and it's 1. So this equals 1 as long as x does not equal 2. Okay. Over here, entire factors. Again, don't try to do the 2 and the 6 or the 6 and the 3, but this entire binomial, x plus 6 and x plus 6, those do reduce. Okay, so there's 1 and 1. But what a lot of people make a mistake of here is they'll say, okay, this equals 2m minus 5 over 3m plus 1, as long as x does not equal. And they only do the one that makes this equal 0. But we have to do what makes both of these. So we got to look at the original problem. What would make the original problem equal 0? So what would make this one equal 0? Negative 6. What would make this one equal 0? And we kind of talked about this trick back when we did quadratics. On this one, we're always going to take that term right there, and when it comes to the other side, it'll be a negative 1. So you really just say switch this sign, divide by that coefficient, because I'm going to divide by 3. So x cannot equal negative 1/3 or negative 6. Sometimes the negative 6 is lost because we canceled it out. It still needs to be included as an excluded value. Kind of a funny thing to say. It's got to be included as an excluded value. Okay, bottom. the 6 and the 3, can I cancel those? And this time the answer is yes, because they're being multiplied. Okay, up here, like this 2 not being multiplied, so I couldn't cancel with that 2. This 6 and that 3, they weren't both being multiplied. Okay, they're not factors, so I can't cancel them. Here, the 6 is by itself being multiplied, so it is a factor. So the 6 and the 3 would be 2 and 1. And this guy, I'm going to write this as n minus 2 times n minus 2. And if you look, n minus 2 and 2 minus n look a lot alike, except they're the exact opposite order. Now if I rewrote this, if I switch the order and put the n first and the 2 second, that sign goes with it. This 2 is positive, so this would be written as negative n plus 2, which is not the same thing as n minus 2. But if I factor out a negative, so if I divide both those by negative, this would be n, and that'd be negative 2. So when you see they're the exact same thing but switched with subtraction, now if they're addition, they are the same thing. But if they're the exact same thing but switched, it's a minus, one's negative, one's positive. Okay. So what I would think is here's a negative, here's another negative, they're positive now. N minus 2 cancels one of those n minus 2's. And if you look at what we have left here, we have 2 times n minus 2 is all that's left. Okay, the bottom all canceled out, but n cannot equal, in this case, what would I plug in to make that equal 0? So 2 minus what equals 0? 2. Okay, so it would reduce, it would simplify to 2 times n minus 2 as long as n doesn't equal 2. Let's see here. So this guy a little bit quicker. Make that does cancel that. So it'd be 1 over 4x minus 1 as long as x does not equal. Okay, remember a trick here. Switch the sign. 1 divided by the coefficient 4. Over here, I'd bring the 3 over. It'd be a negative 3. And then divide by negative 2, so it'd be a positive, so 3 halves. Okay, so the video is getting kind of long, but that's okay. This stuff just takes a long time to do. Okay, so now looking at this one, which one is simplified correctly? Now we could go in all day and we could plug some numbers in here. If I plug, say, 1 here, 1 here, 1 here, and 1 here to see if they equal each other. So 1 squared plus 1 plus 3 over 1 plus 3, does that equal 1 squared? Okay, and that's going to be, this side's going to be 5/4. So 5/4 does not equal 1. So you know that this is not simplified correctly. What someone tried to do was they tried to cancel the x and the 3 and the 3, but they're not factors. You can't cancel those. Okay, so that's not factored correctly. Over here, this is factored. This is not factored. So somebody factored it. Now, x plus 3 and x plus 3, those can cancel, and you get x plus 2 equals x plus 2, and that is correct. Okay, so this one is true. So this is one that's factored correctly. So the difference on the back here is you have to do the factoring yourself. So if you remember from the quadratic unit, we did a ton of factoring. Try to get yourself back into that, that frame of mind of factoring everything. So here, don't start canceling until everything's factored. 4x squared, can't do anything with. But 2x and 6, what are they both divisible by? Well, we could take a 2 out of those. Okay. Now, like I said, it might be easier to do the excluded values first. What would make this bottom equal 0? And that'd be 3. Now, let's do some canceling. So the 4 and the 2, that'd be a 1 and a 2. So I get 2x squared over x minus 3. Don't try to cancel these x's, because this x is not being multiplied by anything. It's not by itself multiplied by anything else. So you can't do that. So this is as far as I can simplify. So if you're understanding this, you can probably fast forward the video a little. Actually, maybe you can't fast forward because I'll play pause it. Never mind. So sorry if you understand it, that's great. I'm going to keep going though. So on this guy, I'm going to factor an x out of both of those. And on the bottom, I'm going to take a 2 out of both of those. Okay, now what would make the bottom equal 0? A negative 4. Now do your canceling. These would cancel out. I'd have x over 2 as long as x does not equal negative 4. Okay, this guy, again, do some factoring. I could take a 4 out of both of those. Okay, so I'd have 2 minus x. And on bottom, I could take an x out of both of these. And I told you on the front side, kind of a long explanation why, but these are the same thing with subtraction, the order's flipped. That means one of them's negative. So if you want to, you can cross them out, make one 1 and make one negative 1. It doesn't matter which one you make negative, it's just one of them's negative. Okay, so now it means it'd be a negative 4 over x is my answer, as long as x does not equal 0 or 2, because that's what would make those two factors equal 0. This guy here, we got quadratics, so think two binomials. What two numbers multiply give you negative 6, add to give you 1. It'd be plus 3 and negative 2. On bottom, product is negative 15, sum is negative 2, so it'd be negative 5 and 3. And kind of a hint on these, when you're factoring, there should be a shared factor because they want you to cancel stuff out. That's the point of the unit, is to cancel stuff out. Now, I'm going to do my excluded values first. It can't be 5, it can't be negative 3. And now do your canceling, x minus 2 over x minus 5. Here, let's see. So this would be x plus 3, because product is 9, sum is 6. Here the product is negative 9. That means if the product is negative, that means one's positive, one's negative. The sum is 0, that means they're the same thing. So these two are the same number. Okay, so now x cannot equal 3 or negative 3. Cannot equal. And my answer, so it'd be x plus 3 over x minus 3. As long as x doesn't equal 3 or negative 3. Here, if you see something like this, we hate when that number is more than 1. So look for, are they all divisible by something? So in this case, I could pull a 3 out of all those. Plus 2x plus 1. Okay, so now keep factoring. Product's 1, sum is 2. That's plus 1. Whoops, plus 1. The bottom, product is negative 9. The sum is negative 8. So that'd be negative 9 and positive 1. Okay, so now we're looking at this over this. X cannot equal 9 or negative 1. If it is, the bottom is 0 and I can't divide it. So now, plus 1, and just leave it factored. I got 3 times x plus 1. You don't have to put 3x plus 3. You don't have to factor it back or distribute it back out. Okay, now these bottom ones are the ones that are a little bit harder to factor because you got to do a little bit more guessing and checking. There's nothing to roll divisible by, so you can't pull anything out front. So if this is 2x squared, that means it must be 2x and x is how they start. I know that the product is negative 10, but now this would be the outer plus the inner product. It's not just the sum of these two. It's going to be outer product plus inner product. And this one ends up being negative 5 and positive 2. So that'd be 4x is negative 5x. 4x plus negative 5x is negative 1. That's how I know I got the right one. Bottom. Again, 3x and x make 3x squared. Product is 2, so it's like 1 and 2 or 2 and 1. And I just put them both down and see which one works. I've already worked these out, so I'm cheating a little bit here, but this is 6x plus 1x equals 7x. That's how I knew. So 6x plus 1x. Now x cannot equal negative 1/3, nor can it equal negative 2. Cancel these out. I got 2x minus 5 over 3x plus 1. Okay, and over here, you may want to start factoring, but to get the answer itself, if you have the exact same thing on top and bottom, you've got the answer. If they're the exact same thing, I can cross those out and say it equals 1. Problem is, I do still need to find my excluded values. So I do need to factor that bottom. And this is one where what multiply give you 28x squared. It could be 28x and 1x. Could be 2 and 14. It could be 7x and 4x. And I happen to know that, so you'd have to guess and check a bunch of these. And then plus 5 minus 3. So if you look, product is negative 15. Outer is negative 21 plus 20, which is negative 1. Okay, and then the first equals 28x squared, so that's how I know it's right. So this would be a negative 5/7, and this would be a 3/4. Okay, so kind of a long video. I apologize. Just a lot of, it just takes a long time to work, so that's what kind of made it so long. But yeah, email me as usual if you have questions.